Hi, today we are going to discuss basic SQL or structured query language. Topics that we are going to talk about, we're going to talk about an overview of what the SQL language is. We're going to talk what is data definition, basic structure and basic operations. We're going to talk about set operations, unions, intersections, etc. We're going to talk about null values. We're going to talk about how to use aggregate functions, things like sum and average and count in queries. We're going to talk about nesting queries and using subqueries and about modification to the database. A little bit of history. IBM created SQL language in the 70s, early 80s. It was then renamed Structured Query Language. The ISO organization, International Standards Organization, took over and started creating versions of SQL. It started in '86 and went all the way to 2003. The data definition language for the structured query language allows the specification of information about relations or tables. This information includes the schema for each relation, what attributes does it include, the domain of the values associated with each attribute, what type of data can be contained in an attribute, integrity constraints, for example, if we can have null values or we cannot have null values. It also includes index files or indices for each relation, issues such as security and authorization, and also physical storage structure on the disk. Domain types. We have many domain types. This slide mentions a few. We have two types of characters. We have fixed length character and variable characters. We have integers and small integers. We have numeric values. We have real and double precision. We have float. We also have date and time. We have blob objects to generic objects containers. We have JSON objects. We have all sorts of domain types that can be used with SQL. The basic SQL structure, we start with creating tables. To create a table, we use the syntax create table, table name, and then we put the attributes, each attribute and its domain values, and we then mention or put if we have any integrity constraints. Let's have an example. For example, if we want to create a table instructor, we say create table instructor, and then we put the attributes and the type for each attribute. Another example is if we want to use the same table, but we add integrity constraints. Integrity constraints are things like, do we allow null values or not? What are the primary key and what are the foreign keys? To do that, let's look at this example. We have create table instructor. We have the parameters here. Name parameter, we added the constraint of not null, not allowing null. And we have the primary key ID and the foreign key department name, which references the department relation or table. Primary key, of course, automatically ensures that the attribute is not null. Another example, here we have the table students. We create it the same way. The table takes, for example, you can see that in the table takes we have two foreign keys. One which is the ID that references the student, and then a compound or composite foreign key that contains the course ID, section ID, semester, and year, which references the section take. Another example is the course, create table course. We have the parameters and the primary and foreign keys. Things that we can do with tables or operations that we can do with tables. We can insert information into tables. We can delete the whole table, and we can alter the table structure. Inserting, the syntax is insert into table name, and then we put the values. and the values have to be of the same type or the same domain for each attribute. If we want to delete, we can use the syntax delete from student. In this case, we are deleting all the tuples or the records from the student table. To delete the whole table, we use the drop table and the table name. To alter the structure, we can either add attributes or drop attributes. If we want to add attributes, we use alter table R add, and we put the attribute name and the domain. If we want to drop an attribute, we use alter table R drop A. In case we add new attributes, if we have existing tuples, the relation will be assigned null for the values of these new added attributes. Basic query structure, the most basic query instruction is the select. The select, its syntax is select, and then we put the attributes from, and we put the relation names. It can be one table or multiple tables, and then we put the condition, the where and the predicate. The result of the select of a select instruction is always a relation or a table. Select. The select clause, it lists the attributes that we want to see as a result of the query. So for example, if I want to find all the names, I say select name from instructor. So it will show only the name attribute. If I want more attributes, I can add more attributes separated by commas. Of course, the attributes are case insensitive. So if I have name like that, or name all capital letters or all small letters, it's the same thing. If we want to select without duplicates, we use the keyword distinct. So we go select distinct department name. In this case, we will only show one name, even if we have more than one tuple or record that contains the same name. So we show only one name. If we want to show the duplicates, we put the we use the keyword all. If we say select all, it will show all the department names in the instructors. Even if they are duplicated, it will show that duplicate. If we want to select all the attributes, we can use the star, select star from instructor. If we have literal attributes, what happens is that if I, for example, select A from instructor, it will create one column with n rows. N rows is the number of tuples or records in the instructor table, and each of them will have the value A. With the select, we can also use arithmetic operations, plus, minus, multiplication, and division. For example, if I want to show the monthly salary, I can say select ID, name, and salary over 12 from instructor. So I'm selecting the ID and the name of the instructor, and also the monthly salary of the instructor. We can provide a name or a heading for the column salary by using the as clause. We use as and monthly salary. So in the result, it will show 3 columns, one headed ID, one headed name, and one headed monthly salary that contains the monthly salary for each instructor. The where clause specifies the conditions. For example, if I want to find all the instructors in computer science department, I say select name from instructor where department name equals computer science. If I have more than one condition, I can combine them using logical connectives and or not. For example, if I want to find all the instructors in computer science departments with salary greater than 80,000, I will say select name from instructor where department name equals computer science and salary is greater than 80,000. The from clause lists the relations. In this case, if I say select star from instructor and teaches, I will do a cross product between the instructor and teaches, a Cartesian product. Let's have some examples. For example, if I want to find the name of all instructors who have taught some course and the course ID, I will say select name and course ID to show name and course ID from instructor and teaches, where instructor.id equals teaches.id. If I want to find the names of all the instructors in the art departments who have taught some course and the course ID, I will say select name and course ID from instructor and teaches, where instructor ID equals teaches.id and instructor.department name equals art. Sometimes we need to rename tables. We can do that. For example, in this case, if I want to find the names of all instructors who have a higher salary than some instructor in computer science, then I have to compare the instructor table with itself. So in this case, the best way to do it is to rename. So I will say select distinct t.name from instructor as t. So I will have a copy of instructor called t and also instructor as s. I will have another copy called s where t.salary is greater than s.salary. So I will find all the instructors in t whose salary is greater than the salary of the instructors in s. And the s.department name is computer science. We can go without the as. The as is optional. We can say instructor as t, or we can say instructor t. String operations. Sometimes if we have string operations, we use the like. Instead of equal, we use the like. And then we use certain characters to show or extract parts or from the strings. If we use the percent character matches any substring. The underscore matches any character. For example, if we want to find all the instructors whose name include the substring DAR, we say select name from instructor where name like, and I use the percentage before and after so that regardless of what comes before or comes after, if it includes the DAR substring, then it will be chosen. If we want to match, for example, the string 100%, then if we put it like that, 100%, it will mean 100 and whatever comes after. So if I want 100%, I have to put an escape character, / escape character before, and I will say like 100 / and the escape is / so that it will not use it as any character. Patterns in string operations are case sensitive. For example, here if I say intro % matches any string beginning with intro, comp % matches any string containing comp as a substring. If I put these 3 underscores matches any string of exactly 3 characters. If I put 3 underscores and a % matches any string of at least 3 characters. Okay. SQL supports a variety of string operations such as concatenation. We can do concatenation using this symbol. We can convert from upper to lower and vice versa, and we can also find the string length and extract substrings. Ordering, we can use the order by to order the results of a select statement. For example, if we want to select the names, select distinct names. So select distinct name will select the names without duplication from instructor, and it will order it by name. We can order it in a descending or ascending order. By default, it's ascending. If we want it descending, we add the keyword descend, DESC. We can also sort by multiple attributes, department name and name. It will sort by department name and then by name. The where clause predicates. The where clause predicates, we can have things like between. If we are, for example, if we want to find all the instructors with salary between 90,000 and 100,000, we say select name from instructor where salary between 90,000 and 100,000. Or we can have more than one tuple in one where condition. So select name and course ID from instructor and teaches where instructor ID and department ID equals teaches ID and biology. So where the instructor ID, it's equivalent to where instructor ID equals teaches ID and department name equals biology. Set operations, like we said, with the set operations, we can use union, intersection, except, etc. For example, if we want to find all the courses that ran in the fall of 2009 and the spring of 2010, we can use select course ID from section where semester equals fall and year equals 2009. And then we union that with select course ID from sections where semester equals spring and year equals 2010. So we will have both of them as results of this query or this set query. If we want, for example, to find the courses that ran in fall 2000 and in spring 2010, we use the intersect. And if we want to find the courses that ran in the fall of 2009 but not in the spring of 2010, we will select all the courses that were given in 2000 fall 2009, except for those courses that were also given in spring of 2010. We can, for example, if we have two queries, we can say we can use, select second query except select first query. We can add queries. We can have queries that are embedded or subqueries used as subqueries in other queries. Like we have said, set operations, union, intersect, and except. And we also have except all if we want to accept all, or intersect all if we want to intersect all, and union all if we want to retain the duplicates. Null values, we said we might have null values if it's allowed by the constraints. Null signifies an unknown. Any arithmetic process with null returns null. For example, if we add 5 in null, if we subtract, multiply, or divide, the result is always null. The predicate null can be used to check for null values. We can say select name from instructor where salary is null, which means that salary is not entered. Null, any operation with null can have one of three values, true, false, or unknown. For example, if we have a comparison with null, then the result is always unknown. If we have an OR, if we have an unknown ORed with true, the result is true. If we have a null with ORed with false, the result is unknown. And if we have a null ORed with null, it's unknown. The AND, if we have a false and unknown, it gives false, otherwise it gives unknown. The NOT will give unknown. If the predicate is unknown, evaluates to true. If predicate B evaluates to unknown. The result is treated as false if it evaluates to unknown. If the result is unknown, or the predicate is unknown, then the where clause is set to false. Aggregate functions, we said that we can use aggregate functions, things like average, minimum, maximum, sum, and count. Let's see some examples. For example, if I want to find the average salary of instructors in the computer science department, I say select average salary from instructor where department name equals computer science. So this will give me the average salary. If I want to find the total number of instructors who teach a course in the spring of 2010, I will say select count distinct ID. Distinct ID because I don't want duplicates. Count will count those distinct IDs from teaches where semester equals spring and year equals 2010, sorry. This will give me all the teachers who, or the number of instructors who taught courses in the spring of 2010. We can find the number of tuples or records in a relation or table by using select count star from course, which will give me the number of all the tuples or records in that course. Aggregate functions, like we say, for example, if we say select department name and average salary as average salary from instructor group by department name, what this will do, it will create a result. This is the result with two columns, one called department name and the other is called average salary. Department name will contain the department names and the average salary will contain the average salary. When I use the group by, I will combine all the duplicates into one value. For example, let's see, attributes in the select clause outside of the aggregate functions must appear in a group by list. So here the result is erroneous because the ID is not included in the group by clause. So in this case, to have the right result, we need to group by department name and ID. Aggregate functions having clause. The having clause, it works in the same manner as where, we can have a predicate. We say select department name and average salary from instructor group by department name having average salary greater than 42,000. Null values with the aggregates. If we want, for example, say select some salary from instructor, it will ignore null values. But if we say select count star from instructor, it will not ignore the null values because we are actually counting records and other attributes might not have any null values. Nested subqueries, we can have a subquery nested in the select or in the from or in the where clauses. Let's see how this is done. Let's see subqueries in the where clause. For example, find courses offered in fall 2009 and spring 2010. We select distinct course ID from section where semester equals fall and year equals 2009 and course ID in, and we perform another subquery or select inside the select the course ID from section where semester equals spring and year equals 2010. So it will give me a result for the course ID that I can compare with these course ID to get the required result. For example, find courses offered in fall 2009 but not in spring 2010. We say select distinct course ID from section where semester equals fall and year equals 2009 and course ID not in. In this case we used in, this case we used not in, so that not in spring 2010. So it will not select any of the course IDs that are the result of this query. We can also, for example, find the total number of distinct students who have taken course section by a certain instructor. We say select count distinct ID from takes for the students where course ID, section ID, semester and year in. Select course ID, section ID, semester and year from teaches where teaches ID equals 10101. For example, if we want to find the names of the instructors with salary greater than that of some, at least one instructor, like we said, we say select distinct t.name from instructor as t, instructor as s. We rename it because it's the same table. We're comparing the table against itself, where t.salary is greater than s.salary and s.department name equals biology. We can use some. Select name from instructor where salary is greater than some. Select salary from instructor where department name equals biology. So it will show it even if it's greater than at least one of the teachers. This query and this query perform the same thing or do the same thing. If we want to find the names of all the instructors whose salaries is greater than salary of all the instructors in the biology department, we will say select name from instructor where salary is greater than all. Select salary from instructor where department name equals biology. So it's greater than all of the salaries of the instructors in the biology department. The exists, another way is to use the exists clause. For example, if you want to find all the courses taught in both fall 2009 and in spring 2010, we say select course ID from section as S, where semester equals fall and year equals 2009, and exists select star from section as T, where semester equals spring and year 2010, and s.course ID equals t.course ID. If we want to find all the students who have taken all courses offered in the biology department, we say select distinct s.id, s.name from students as S, where not exists, select course ID from course where department name equals biology, except select t.course ID from takes as t where s.id equals t.id. Here we will take only the courses, the biology courses, and not the other courses where we might have students taking these courses. If we want to test for the absence of duplicate tuples, we use unique. So we say select t.course ID from courses as T, where unique, select r.course ID from section as R, where t.course ID equals r.course ID and year equals r.year equals 2009. So we will find all the courses that were offered at most once in 2009. Subqueries in the from clause. We can use subqueries in the from clause. If we want to find the average instructor salaries of those departments where the average salary is greater than 42,000, we will go select department name and average salary. From select department name average salary as average salary from instructor, a group by department name. This will create a table with two columns, department name and average salary, and I will select department name and average salary from this table where the average salary is greater than 42,000. So I will create a table in this subquery, and then I will use it to select all the department names with average salary that is greater than 42,000. You can do it in two separate queries, but here we are doing it in one query. Okay. Another way to write the above query can be select department name and average salary from select department name average salary from instructor, group by department name as department average. We will create a table called department average that has department name and average salary, and then we will use this. We will select the department name and average salary from this department average where the average salary is greater than $42,000. We are using renaming here for the table or the relation also. With clause, the with clause provides a way of defining a temporary relation or table that is only available with the query. For example, find all the departments with the maximum budget. I want to create a table, so I will say with maximum budget value. I will create a table with one column value as select maximum budget from department. I will select the maximum budget from department and put it in this table, and then I will select the department name from department and maximum budget, which is the table that I have created, where department.budget equals maximum budget dot value. So in this case, I will the output will be all the department names whose budget is equal to the maximum budget value. Complex queries using the with clause. For example, if we want to find all the departments where the total salary is greater than the average of the total salary at all departments, we use the with clause to create what we call department total relation that contains two columns, department name and value. As select department name and sum of salary, we will select the department name and the sum of salaries in that department from instructor, and we group it by department name. So we'll only have we will have no duplicates. We will have one occurring or one occurrence of each department name, and then we will create another table or relation called department total average with one column value as select average value from department total from this one, and we will create the average value, and then we use these two in the following query: select department name from department total and department total average where the department total dot value is greater than the department total average dot value. So I will select all the departments whose total salary is greater than the average of the total salary at all departments. Subqueries in the select clause. We can have select department name and select count star from. So we will have two attributes, the department name and the count. And we will call the count number of instructors from department. So the result will be a table of two columns, one called department name and contains the department names, and one contains the number of instructors that will have the number of instructors in each department. How do we modify databases? Like we said before, with tables, we can delete tuples from a given relation or table. We can insert, and we can update the values of attributes in tuples. Deletion, we can use delete from instructor. For example, we delete all the records from instructor, or we can say we can have a where and a condition. For example, if we want to delete all instructors from the finance department, we will say delete from instructors where department name equals finance. Or if we want to delete all the tuples in the instructor relation for those instructors associated with the department located in the Watson building, we'll say delete from instructor where department name in, select department name from department where building equals Watson. So it will select all the department's name in the Watsons, and then it will delete from instructor the tuples that the department name is in the Watson building. We can also, for example, if we want to delete all the instructors whose salary is less than the average salary of the instructors, I will say delete from instructor where salary is less than select average salary from instructor. So we will delete delete all the tuples where salary is less than the average salary. There is one problem with this, is that as we delete tuples from deposit, the average salary changes. Solution: first we compute the average salary, for example, with clause or other things, and find all the tuples to delete. Next, delete all the tuples found above without recomputing average or retesting the tuples. Insertion: we can insert, for example, insert into course values, and we put the values in the order of the attributes and based on the domains. Or equivalently, we can say insert into course, and we put the attribute names and the values. If I want to insert a new tuple with a null value, I can insert and put the null value where the total credits are. We want to add all instructors to student relation with total credits set to 0. So we say insert into students, select ID, name, department name, and 0 from instructor. Okay, so I select the ID, name, department name. 0 is literal, so I will have a column that will have the total credits set to 0. Inserted and set to 0. Select from where statement, we can say is evaluated fully before any of its results are inserted into the relation. So queries like this one without the where clause may cause problems. Update, we update part of the attributes in the tuples. For example, if we want to increase the salaries of instructors whose salary is over 100,000 by 3% and all the others by 5%. We can write the updates as two updates. Update instructor set salary equals salary times 1.03, where salary is greater than 100,000, and then update instructor set salary equals salary times 1.05, where salary is less than or equal 100,000. Now, if the order is important here, if we do this one before that one, some of the salaries might cross the 100,000 limit, and thus will get another raise as part of this query. It can be done in a better method using the case statement. So let's take a look at it. We can say update instructor set salary case. When salary is less than, then salary is times 1.05, else salary times 1.03. So if we use the case, it will solve the problem of the order. Updates with scalar, we can update total credits values for all students if they have. Otherwise, we can put zeros. This, the meaning of this is that we can use scalar values we can update using scalar values and not values for the domain. Thank you.